Assalamualaikum warahmatullahi taala wabarakatuh. Selamat tengah hari and good afternoon. Right, I will go to a new topics on kinetics. In kinetic, there are, if I'm not mistaken, there are two topics. First one will be on force. The other one will be the momentums or impulse and energy. So today we of using the force or impulse, we're using the kinetic study. I'm using the work and energy. Right. So this work and energy methods, right? Not really work energy methods, but kinetic, right? You do the kinetics, but you solve using you are considering the energy approach, right? You look at the energy part of it. The approach is similar with the thermofluid engineering. So I just want to know whether you already take thermofluid engineering or thermodynamics. Please let me know. Thank you for answering that questions. Have you already covered the energy balance? Right. I don't know how many of you take a matriculation. Have you solved the energy equation delta U equal to Q minus W? Anyone familiar with this equation? Right. If no one familiar with that equation, have anyone heard about conservation of energy principle? I'm glad to hear that. Right. So, what is the energy principle, Mashita? Voice, audio. Let me hear your audio. Not right.
Like energy cannot be destroyed, but it can be transferred.
Right. Can it be created? Can the energy be created? Right. So Mashita said energy cannot be created. Are you is created or not? Now Mashita answer that question. Is human being is created or not? Right. So in my lecture, I don't teach students to say that energy cannot be created, energy cannot be destroyed. I don't teach that in my class. What I teach in the class is that energy can only change form. So remember that. Don't say that energy cannot be created, energy cannot be destroyed, right? Especially to the Muslim student, right? Or even the Christian student, they don't say that. Or Jewish student. So we only say that energy can only change form. Right. So this statement can be quantified using an equation, and that equation is called energy balance. This is an equation called energy balance. The left hand side says that there will be a change of total energy of the system, and if there is a change of total energy in the system is equal to energy being added to the system minus energy that leave from the system, right? So this is the general form question. Now I'm expand the right hand side and list down the energy that can be added, the energy can be removed from a body, right, from a system that you are interested in. The system can be particle, the system can be rigid body, right? A rigid body that move in the um, plane motion, right? And that energy added and energy leave the body consists of two. Q represent heat, W represent work. So in dynamic, when we study kinetics, we not consider the heat, right? So we have, if there is a changes of energy for the particle or for the rigid body, it's all due to the amount of work added and amount of work that been removed from the body. Now I expand the left hand side of the equation of the energy balance, right? So we have the total energy of the system consists of the internal energy, right? Internal energy means the motion of molecule in the body, and it causes the temperature changes in the system, in the body. And then we have the kinetic energy, which depends on the kinematic properties of the body. And then we have PE. PE is a potential energy. It just tells us about the changes of position of the body, right? So the statement of first law of thermodynamics, which is a statement of conservation of energy principle, um, is applied on the left hand side, right? If the right hand side is zero, if there is a changes of kinetic energy, if the system does not change its temperature, so it will cause changes in the potential energy. Right, and then we can define the variables here. The term in the equation on the left hand side, the kinetic energy is defined by half, and then the mass times the velocity. The velocity is a resultant velocity of that body, power of 2 plus half time the moment of inertia time the angular velocity of that body, power of 2, right? So if you are solving particles, there will be no, the second term can be considered zero. If we solve a rigid body, then we find that if the body is having a general translations motion, general plane motion, so you find the value of the right hand side is not equal to zero, right? So if the rigid body is having a pure rotation, so the kinetic energy due to the translation will be zero. um, and then we have the potential energy. Potential energy means that you need to know about the mass of the system, the gravity of the system, and the elevation. And this elevation must be measured in the direction of acceleration vector due to the gravity.